Okay, this video is going to be taking a look at derivatives of natural log of x and e to the x. So the first thing I want to do is let's take a look at what your graphs are going to look like for each of these, as well as the derivative graphs. We're going to start with natural log of x as a graph, so let's just pull up this graph. Alright, so this is the graph of y equals natural log of x. The red graph is. And if you look at your tangent line, when this tangent line moves closer to the y-axis, you're going to notice that your tangent line is going to be getting closer and closer to being a vertical line. Now, as that tangent line moves further to the right, you'll notice that it starts to flatten out or get closer and closer to a slope of 0. What that means is that your derivative is getting closer to 0. Over here, close to the y-axis, it has a very steep slope, which means your derivative, which is the blue dot, is going to be a large number, and it just keeps getting larger and larger. Now, as you move this way, you have a slope of the tangent line is 1, so you see the blue dot at 1 for the to represent the derivative. And as you move to the right, your derivative, which is the blue dot, gets closer to 0 because the slope of the tangent line gets closer to 0 as we move this direction. All right. So what you get then is the graph of y equals 1 over x. You're only getting the right side, or the positive branch of 1 over x, because you can only take the natural log of positive numbers. Okay, and so what that does is it gives us this equation, or this formula for a derivative. Your derivative is going to be 1 over u times du dx. And remember, this du dx part right here is just simply the chain rule. That's multiplying by the derivative of this value, which is this right here. Okay. All right, so the next graph we're going to look at is going to be e to the x. And for e to the x, you see your tangent line in black, which is your dotted line here. And the tangent line, as you move to the left, is going to get flatter and flatter and flatter, getting closer and closer to a slope of 0. It does not actually ever really get there, it just gets really close. This graph right here is the graph of y equals e to the x. And you can see right here the tangent line has a slope of 1. Over here it's getting closer to a slope of 0, which also is the same as the y values. Here the y value of the function is 1, and so is the slope of the tangent. And as you move this direction, your y values are increasing, and the slope of this tangent line, or derivative, is also increasing. Now, what you'll notice in blue is that we have in blue the graph of the derivative of e to the x, and in red is the graph of just the original function, e to the x. Now, you can see on this graph you don't see the red one, but let me just take the derivative graph off, and when I do that, you'll notice that the red graph is there. The red graph, e to the x, the blue graph, the derivative of e to the x, are the same graph. So what that leads us to then is this definition, or this formula, that the derivative of e to the u is its own derivative. It is e to the u. And then again, chain rule, times du dx. All right, so let's work through some problems here with our derivatives. Now that we have some formulas to go by. On this first problem, the 6 is just a coefficient, so we can just bring that down. And then we're going to find the derivative of natural log of this. Now, this is your u value. So the derivative of natural log of u is 1 over u times, and then the derivative of u, which would be 4x plus 3. Now we could put this together in one of two ways. We can either say 6 parenthesis 4x plus 3 over the denominator, or you could distribute the 6 and get 24x plus 18 over the 2x squared plus 3x. Either one is okay. All right, so the next one, we have a fraction, which means we're going to be using quotient rule for this derivative. And for your quotient rule, you're going to start out with the bottom, which is 3x, multiplied by the derivative of the top. Now the derivative of the top, we've got two terms in there. So the first term, the derivative is e to the 2x times the derivative of the exponent, which is 2. All right, so that's the derivative of the first term. And then you have minus, and the derivative of e to the x squared is e to the x squared times the derivative of the exponent, which is 2x. All right, so that is bottom times the derivative of the top. Now we have minus the top times the derivative of the bottom, which is just 3. And all of this is over the bottom squared, and if you square 3x, you end up with 9x squared. Now, one of the things that we can do for simplifying is that you'll notice in this and this, they both have a 3 right here and right here, and our denominator has a 3 also that we can pull out of this 9. So what that means is that we can cancel this 3 with this and change this to a 3 in your denominator. So your cleaned up answer will look like this. Distributing the x, you're going to get 2x e raised to the 2x minus 2x squared e raised to the x squared minus e raised to the 2x. Distribute the negative, making it plus e raised to the x squared. And all of this is over 3x squared now. That is going to be your simplified version of your derivative. All right, so the next problem is e to the 4x times sine of 2x. Multiplication in between here, which means we are needing to use product rule. So product rule starts out with first times derivative of the second. So the derivative of sine of 2x is cosine of 2x, and then times 2 for your chain rule. All right, so that's first times derivative of the second plus second times derivative of the first. And the derivative of e to the 4x is e to the 4x times the derivative of the exponent, which is 4. And about the only thing that you could do on this for simplifying is bringing your coefficients to the front, giving you this plus 4e to the 4x sine of 2x. That's about all that we can do with this. All right, so the next problem, looking at the derivative of this. Well, this is your u value. So the derivative of e to the u is e raised to the u. But then we have to multiply by the derivative of that exponent, which would be 3x squared plus 2. Now, because we are doing two terms right here, this does have to be in parentheses. If you did not put the parenthesis right here, the only thing that would get multiplied is your 3x squared with this. The whole thing is what needs to get multiplied, so you must put parentheses around that. All right, so the next problem, what I would do in this situation is I would convert your radicals to exponents. So I would rewrite this as x raised to the 1/2 power times e raised to the x to the 1/2 power. There is multiplication in between here, meaning we are going to be using product rule. All right, so the product rule is going to start out with first times derivative of the second, so the derivative of e to the x to the 1/2 is e to the x to the 1/2 times, and then this is your u value, so we need to multiply by the derivative of that, which would be 1/2 x to the negative 1/2. All right, so that's our product rule, first part of it. That's first times derivative of the second, plus, now we have to take the second term and multiply it by the derivative of the first term, which would be 1/2 x to the negative 1/2. All right, so here what we're going to do is distribute. So, well, actually there's nothing to distribute. I take that back. There's multiplication here. This is all multiplication. So we are multiplying this by this whole thing. Remember that when you multiply variables together, you add your exponents. So when you multiply x to the 1/2 times x to the negative 1/2, that is going to give you x to the 0 power, which is just 1. So the only thing that you're going to be left with in this is going to be e to this power over 2, where the 2 came from right here, and we had this. This times this was our 1. All right, so now we have plus. Now this, nothing cancels, nothing combines together, so you're going to have e to the x to the 1/2 over 2x to the 1/2 power, where this had a negative exponent, so this term is going to go to the denominator with the 2, giving us this right here. All right, and one more problem here. On this particular problem, we have division, which means we're going to be using quotient rule. Quotient rule will start out with bottom times derivative of the top, and the derivative of the top will be 1 over the u value times the derivative of the u value. So that's bottom times derivative of the top minus the top times the derivative of the bottom. Well, the derivative of the bottom is e to the x plus 2. And all of this is over the denominator squared. All right. There's really not a whole lot that we can do to simplify this. So we're just going to leave our derivative in this format right here. All right, so now it's time for you to practice your assignment on natural logarithm and e to the x or exponential derivatives.